Okay, good morning BSRT2 students. So we are already through the discussion of our X-ray imaging system, particularly on the X-ray tube, the operating console, as well as the different X-ray machine accessories such as the X-ray film, the cassette, ano pa, and siguro yun lang. So for now, we will proceed to the overview of the X-ray exposure factors. So actually, ito yung magiging heart ng discussion ng ating subject on RT 213, which is Principles of Imaging. So tignan niyo ha, the exposure factors. So since we know that radiography is an art and a science at the same time, so to produce radiographs, the radiographer operates equipment that will produce X-rays. To do so, radiographer must be skilled in the use of technique factors that consistently produce radiographs or good radiographs. So, like what you can see in our illustration, so Mr. Chester Asuncion is having a film critique. So, later on, once matapos na kayo sa program na ito, so, you are expected to produce a good quality radiograph. So, for you to do this, kailangan meron kayong technique. So, ito na yung mga sinasabi natin kanina sa title, the technique factors or the exposure factors. So, your X-ray film will now become a representation of yourself. Kaya nga, sabi dito, it's an art and at the same time, a science. So, yung application ng mga matututunan nyo dito sa subject na to will be applied in your day-to-day profession, being a radiologic technologist. So, again, I said, this is a representation of yourself. Kasi kung maganda yung quality ng radiograph, so it means that you are a good quality radiographer. Tama ba ako? So, kung pangit naman, huwag na tayong magtaka. Okay, so that's also true. Kaya, pinag-aaralan natin dito how to produce a good quality radiograph. So, ito. Technique is the systematic procedure used by the radiographer to accomplish the task of producing a high-quality radiograph. This systematic procedure includes the ability to select appropriate factors to produce an X-ray beam that will adequately penetrate the body part that provide the appropriate level of blackening or the density and the subject contrast on the radiograph. So, kung makikita nyo sa operating console ng University of Eastern Philippines, mapapansin nyo to. So, we have there these radiographic technique charts, kasi marami yan. These were produced by the former BSRT2 students, so they were promoted as BSRT3 students now. So, may mga ginawa silang radiographic technique factor charts, which it was personalized. Kumbaga, sila yung gumawa ng mga sarili nilang technique. So again, technique, this is a systematic procedure. Kasi, pansin nyo dito for chest, mayroong mga view for certain procedures, view or position. Tapos, meron ditong appropriate value. So, these were tested by my students for MA, KVP, MA, distance, at saka yung kung gagamit ba tayo ng grid or not. So, this is again, yung purpose why we have to do this? Kasi nga, if you are now a radiographer or a radiologic technologist, this technique factor chart will now serve as your guide. Para hindi na kayo from time to time gagawa ng ibang factor for the same for example, iba-ibang patient, but the same anatomy, at least you already have the guide. So, alam nyo na kung ano yung magiging KVP, ano yung MAS for that particular procedure. So, this technique factor chart will now, again, be your technique all throughout your procedures. So again, this is systematic kasi tinest muna ito ng mga estudyante for UEP. So it has been tested by my students prior to submission of these technique factor charts. But sad to say, at this moment, due to pandemic, so I won't expect you, or definitely you cannot produce your own radiographic technique chart. Ano? So again, sabi dito, these technique factor chart are needed to produce radiograph with appropriate level of density and of course of contrast. I guess Mr. Chan can relate to this because I know he is an artist. So alam niya yung density probably and contrast, which we'll be talking it right away. So to produce a radiograph, the radiographer selects and manipulates 4 significant factors. So we have the kilovoltage, milliamperes, exposure time, and distance. So the knowledge of how all these factors interrelate and combine with each other to produce a diagnostic radiograph is the science of radiography. So radiographers must understand how each factor functions in the production of X-rays, penetration of the human body parts, and absorption of body tissue, and how each factor produces changes in film density and subject contrast. So most of these technical factors will be found in your operating console. So nandun yung KVP, nandun yung MA at exposure time. They are combined as a single exposure, MAS. The distance is of course, as RadTech, kayo na yung mag-identify ano yung from the certain point. So ano yung placement ng X-ray tube nyo for a specific distance. Ano? I hope you can get me. So, itong mga technique factors, KVP, MA, exposure time, and distance will be used to produce a good quality radiograph because a change from one factor to another will have an effect. May have or may not have an effect to the other factors. Sige, later we will discuss each of them. Ano? So, first, we have the kilovolt peak, or this is what we call the KVP. So, makikita yan sa ating operating console. So, let's define what is KVP. So, kilovoltage is defined as the force applied to accelerate or to push the electrons from the cathode to the anode at the time of the exposure. If it was appropriate to select one factor, KVP would be the most significant factor in the production of X-rays and radiographs. So the selection of a particular kilovoltage setting affects the speed at which electrons travel from the cathode to the anode in the X-ray tube at the time of the exposure. In turn, the force behind the stream of electrons determines the speed at which electrons slam into the focal spot. So, again, this is just self-explanatory. So, this is the force of the projectile electrons that are coming from the cathode traveling to the anode. What else? So, the force produced by the voltage applied between the cathode and the anode can be graphed as waveform. Actually, this is what we call the voltage waveform in our equipment maintenance. So the waveform shows that as soon as the voltage reaches its peak, it falls to 0. Only a portion of this waveform is useful in producing a radiograph. So the highest level of energy, or the crest of the waveform representing X-ray photon energy, is referred to as the kilovolt peak. So ito, so this is we can say that this portion of the waveform is the most particularly useful portion of or energy of the photon that will contribute to the production of a good quality radiograph. Kaya peak, di ba? When we say peak, pinakamataas, di ba? The highest point of a waveform. So, that is why ang tawag sa kanya kilovolt, so the peak. So, tigam niya, if you are going to write that into or abbreviate that is small letter K, capital letter V, and small letter P. So the kilovoltage selection determines the wavelength of the X-ray photons. An increase in kilovoltage will produce shorter wavelength X-ray photons with greater ability to penetrate body tissue. So kilovoltage is the factor that determines the energy of photons. So with greater ability to penetrate body tissue. So when we say again energy, so that is related to the kilovolt peak, or it is abbreviated as KVP. Energy, penetrability, so that is KVP. So, yun pala yung gamit ng KVP. So, in our console, may kita nyo dyan, meron dyan KV, or the KVP, kilovolt peak. Again, kaya tawag na peak kasi this is the highest point in a waveform. So, to understand KVP as an exposure technique factor, assume that KVP is the primarily control of X-ray beam quality and therefore beam penetrability. So a higher quality X-ray beam is one with higher energy that thus more likely to penetrate the anatomy of interest. So KVP controls the screen film radiographic contrast. So yun. So atigan nini ha, KVP. So anong sabi natin kanina? The force. Other than that, we have the energy, penetrability. So, may bago dito. Quality. Yan. And, of course, the contrast. So, yun yung mga kinokontrol ni KVP. Madami ba? So, the KVP has more effect than any other factor on the image receptor exposure because it affects beam quality and, to a lesser degree, influence the beam quantity. With increasing KVP, more X-rays are emitted and have higher energy and greater penetrability. Unfortunately, because they have higher energy, they also interact more by Compton effect, and produce more scatter radiation, which results in reduced image contrast. So, kanina, sabi natin, KVP controls the contrast. However, this is also pala true that KVP affects the density. So, the higher the KVP pala, mas magiging black yung film due to scatter radiation, to Compton effect. So, i-review natin what is what is scatter radiation. So, from the X-ray tube, so we have the useful beam. So, this useful beam, some of which can interact with they will interact with the anatomy of interest or the patient. So, those that exit and will interact with the image receptor, they are now called the remnant radiation. Those radiation that exits the human body, however, they do not interact with the image receptor, are called scatter radiation. So, the more scatter radiation, of course, some of which may mga mapupunta sa image receptor, So, this will contribute to reduced image contrast. So, yun pala yung disadvantage of a higher kilovolt peak. So, the KVP selected helps determine the number of X-rays in the image-forming beam and hence the resulting average optical density or the OD. Finally, and perhaps most important, the KVP controls the scale of contrast on the finished radiograph because as the KVP increases, less differential absorption occurs, therefore high KVP results in radiographic contrast. So, kung makikita nyo ito, lahat ng ito, so that will be, so from white to black. So, each one is representing a different density. So, less ang density niya kasi whiter pa siya. So, high ang density niya kasi black na siya. So, the difference, yung kaibahan ng kanilang shade, is what we call the contrast. So that is why there is what we call the scale or the scale of contrast. So each of the box again represent different density, white and blackest. So the range from whitest to black is na what we call the scale of contrast. So yun yung kinokontrol ni KVP, the scale of contrast from the white to black. So average, halimbawa to 1 2 1 2 3 4 5 6 7 8. So we can say that the average contrast is here ng iyong film. Okay? Sige. Next, we have actually this is just an overview. Meron pa tayong detailed explanation about the KVP, about the MAS or MA and exposure time. So pinapakilala lang natin that these technical factors are important for you to produce a good quality radiograph. So next probably mga next succeeding sessions, we will identify how to appropriately or how are we going to get the appropriate KVP for a particular exposure, how are we going to get a MA or MAS for a particular exposure. So for now, it is just limited as to the overview or introduction of these technical factors. So we have the milliampere or the MA. So the second important technique factor is the milliampere. So it is defined as the current flow through the cathode filament at the time of the exposure. So recall that the unit of electric current, ampere, so 1 ampere is equal to 1 coulomb of electrostatic charge flowing each second in a conductor. Therefore, 1 ampere equals 1 coulomb per second, or there are number of 6.3 times 10 raised to 18 electrons per second. So this, in which we can say that for every 1 ampere, there are 6.3 times 10 raised to 18 electrons per second. So how about ano pa yung mga direct bearing ng MA? So the amount of MA selected at the time of the exposure controls the current flow through the cathode filament. So an increase in MA will increase the current flow, and the temperature of the filament will rise. Therefore, as the filament temperature rises, applying the thermionic emission, the number of electrons from the filament during thermionic emission will definitely increase. Okay, so and this cloud of electrons, as a review, this is what we call the space charge. So an increase in MA yields a greater number of electrons in the space charge available for producing X-ray photons. Okay, so again, MA, we are particularly on the number of electrons. So the increase in MA will increase the amount of X-ray photons produced at the anode target. So an increase or decrease in MA is represented as a quantitative factor. So the purpose of increasing MA is to increase the number of electrons available to travel from the cathode going to the anode, producing more X-rays. So number of electrons yung pinag-uusapan sa milliampere. Sa KVP class, do not forget the energy of the X-ray photon. Sabi nga kanina, the energy or the force that is needed to push these electrons para mag-travel siya from the cathode going to the anode. So, yung number of electrons na produced with the use of MA, and para mapunta siya sa target or sa focal spot, yung kailangan nating energy is ginawa ni KVP. So, nakita nyo na yung kaibahan ng dalawa. So, pag sinabing number, yung dami ng electrons na dapat mag-produce ng X-ray, ginagawa ni MA. Yung bilis ng mga electrons na makapag-travel from the cathode to the anode ay ginagawa naman ni MA. So, the MA selected determines the number of X-ray photons produced and therefore the radiation quantity. So, kanina sabi natin KVP, energy, penetrability, quality, tapos contrast. Dito, sinabi natin kanina, MA number, so therefore this is quantity. So as more electrons flow through the X-ray tube, more X-rays are produced. Assuming a constant exposure time, this relationship is directly proportional, in which change from 200 to 400 mA would be a 100% increase or doubling of the number of tube current. Ano? Kasi sabi nga natin kanina, the higher the MA, so technically mas mainit yung tungsten, thoriated tungsten. So mas mag-iinit yung filament at saka mag-i-increase yung production ng electrons around the filament. So, and a doubling of patient radiation dose. With a constant exposure time, MA controls the quantity and therefore the patient radiation dose. Okay. So, a change in MA does not change the kinetic energy of the electrons. Take note, from the cathode to the anode. Kasi sabi natin, yung magkocontrol nito is, ano ulit? Very good, a KVP. So, it simply changes the number of electrons. Consequently, the energy of X-rays produced is not changed. Only the number is changed. Okay, so X-ray quality remains fixed with change in MA. Kasi hindi niya makokontrol si quality. Si quantity yung kinokontrol niya. However, si KVP pwede niyang makontrol yung dalawa due to very good scatter radiation. Next. Galing talaga ng mga BSRT2 students. Okay, so we have exposure time, which is translated in a form of second. So exposure time is the technical factor that sets the length of time for an exposure. Buti pa daw yung exposure factors may time, samantalang siya wala. So it is also a quantitative factor that, when combined with MA, determines the exposure rate. So MA times time. So therefore, this is the current or the rate of current. Diba? So current per unit of time. So radiographic exposure times are usually kept as short as possible. So the purpose is not to minimize patient radiation dose, but rather to minimize motion blur that can occur because patient motion. So tigam ni. Actually, sa radiation protection, importante dito yung time. Pero sa technique factor chart, so ginagawa natin yan to minimize the motion. Nagiging secondary na lang yung radiation protection. Ano? Sige, ano pa? Producing a diagnostic image requires certain exposure of the image receptor. Therefore, when exposure time is reduced, the MA must be increased proportionately to provide the required X-ray intensity. Again, when X-ray exposure time is reduced, the MA must be increased. So they are inversely proportional, okay, to provide required X-ray intensity. Okay, so we have MAS. So this is MA and exposure time combined. Ano? MA and exposure time, that is in seconds, are usually combined and used as MAS. Indeed, many X-rays or X-ray consoles do not allow separate selection of MA and exposure time and permit only MAS selection. So, mag-cut muna ako dito. Like in our school, in our university, baka ma-confuse kayo, sir, nasaan dyan yung MA, nasaan yung exposure time? Kasi, in our console, we only have one selection that is only MAS. Meaning, nandun na yung MA, nandun na yung exposure time. They are now combined. So, based on the calibration, MA is set at 200. Okay, so MA is set at 200. So, which means 32 divided by 200. So, what will be our exposure time? Sige nga, compute mo nga. Wow, volunteer. Sige, 32 divided by 200. So, what is our exposure time? So, 0.16 seconds. Or, that is 16 millisecond. Ano? So, yun. So, pwede mong makuha yung exposure time based on sa computation because our MA, in our university lang ha, is set at 200. So, Although the radiologic technologist may be required to select exposure time, it is always selected with consideration of the MA station. So the important parameter is the product of the exposure time and the tube current. So the MAS value determines the number of X-rays in the primary beam. Take note, MAS, parehas kanina sa MA, number of X-ray photons. Therefore, this is also the radiation quantity. And in the same way that MA and exposure time, they can do, it does not influence radiation quality. Ano? Oraya labot sa quality. Quantity lang eraginhi mo kasi quality only KVP. However, take note class that KVP does affect quantity at the same time. So the MAS setting is the key factor in the control of the optical density on the radiograph. Kanina sabi ko, combined together, initanan, so scale of contrast na siya. But each box is the optical density. Again, if galing dito, so from white papunta sa black, each box is what we call the optical density. Okay? So, meaning the optical density differences can be or is termed now as the scale of contrast. Okay? So, if the high voltage generator is properly calibrated, the same MAS value and therefore the same OD can be produced with various combinations of MA and exposure times. Because X-ray tube current is electron flow per unit time, the MAS value is therefore simply a measure of the total number of electrons conducted through the X-ray tube for a particular exposure. So, yung makikita nyo sa picture, this is the calibration process. Sabi nga dito, if the high voltage generator is properly calibrated, so the same MAS value and therefore same OD can be produced with various combinations of MA and exposure time. So calibration is performed as part of our equipment maintenance. So because of X-ray tube current is the electron flow per unit time, so the MAS value is therefore simply a measure of the total number of electrons. Okay? So yun lang, yung the key term to remember is MAS, the number of electrons, so the quantity, and therefore it controls the optical density. So, on an X-ray imaging system in which only MAS can be selected, sabi ko nga sa UEP, we only have here, MAS lang yung nandun. So, exposure factors are adjusted automatically to the highest MA at the shortest exposure time allowed by the high voltage generator. Such design is called a falling load generator. Yun pala yun. So, because of the falling load generator, nakaset automatically yung MA to the highest value, therefore, or whereby giving the shortest possible exposure time. Okay po? So, varying the MAS setting changes only the number of electrons conducted during an exposure, not the energy of those electrons. Kasi nga, ulitin ko lang nga, energy, this is controlled by KVP, not MA, not exposure time, either not MAS. So the relationship is directly proportional, which means doubling the MAS doubles the X-ray quantity. The same way around. So if it is reduced into half, so magiging half yung X-ray quantity. Only the X-ray quantity is affected by changes in MAS. Okay, so any questions? Of course, hindi nyo magagawa kasi nasa virtual classroom tayo. Ako lang yung sasalita. Next, of course, ito yung sinasabi ko kanina. So, yung KVP, yung MA, yung exposure time, or MAS, can be found in your operating console. However, this last technical factor, the source to image receptor distance, wala na dun sa technical sa operating console. This is now in your exposure area. So, sa exposure room. Like yung ginagawa ni John na, tingnan nyo, there is the measurement. So, this is now the SID for a certain procedure. Okay, so distance affects exposure of the image receptor according to the inverse square law. So the SID largely determines the intensity of X-ray beam at the image receptor. It is measured from the focal spot to the recording medium. Galing dito, papunta sa film. So yun yung tinatawag nating SID. So, formerly known as focal film distance, pero binago na siya. Dati tawag FFD, ngayon SID na siya. So, this represents the length of space from the focal spot again to the recording medium or to your X-ray film. Sige. So, distance maintenance law or the direct square law is derived from the inverse square law. It allows the radiologic technologist to calculate the required change in MAS after a change in SID to maintain constant OD. Okay. So, kung makikita nyo sa illustration, so, meron ditong light at saka a specific distance. So, imagine na lang if you are holding a flashlight in your hand. Pag malapit yung wall, so makikita mong bright, masyadong bright. So you move further, malayo-layo ng konti. So nag-change na siya. Hindi na siya gaanong bright. Kung malayo na, so madilim na siya. So ano yung implication? So yung intensity ng X-ray beam masyadong malakas, if it is closer to the image receptor. Kaya may tinatawag dyan na distance maintenance law, which is derived in the inverse square law. Sa inverse square law, ganito yung mangyayari. Kung okay, so since the closer, the higher the intensity. So yung, that's the inverse square law. So the farther naman, the lower is the intensity. So, yung gagawin natin sa distance maintenance law, okay, so since sinabi natin na mas malapit, the closer, the higher is the radiation intensity, so imagine mo na lang sa X-ray film. Kung malapit yung X-ray film sa X-ray tube, therefore, we have to assume na malakas yung X-ray intensity. So, therefore, para hindi masyadong maitim yung radiograph, so, a-apply na natin si distance maintenance law, which means we are going to reduce the MAS nakuha para to compensate the intensity kasi nga malapit siya masyado. So, we are going to reduce the MAS para hindi sunog graphy. Okay? So, para lighter din naman yung image. Nakuha po yung application ng inverse square law at saka distance maintenance law. Sige, so you can raise your question din naman through our different platforms if you have time. So do not hesitate po. So standard SIDs have been in use for many years. So for example, dito kanina kay Jonah, so this is what we can say, this is 40 inches. So mostly for extremities. So standard yun. Standard for tabletop radiography, 100 cm or 40 inches is common. But dedicated chest radiography, tawag natin dyan is teleoradiography, 180 or 72 inches SID. So, tabletop radiography at 120 and chest radiography at 300 cm are now often used. But again, ito yung standard natin. 100 cm for tabletop and 180 cm for chest teleoradiography. So, the use of longer SID results in less magnification. So, imaginein mo yung magnifying glass. Pag malayo, hindi ba, less ang magnification niya. Pag malapit, ayun, kitang-kita yung mga hindi dapat makita, mga alikabok, langgam, and whatsoever. So, para hindi mas magnified yung image mo, we have to apply the higher SID. That's another effect sa radiography, pero sa image na yon. So, pag closer pala yung X-ray tube doon sa ini-X-ray, so mas magnified yung image. Pag mas malayo, less yung magnification. Ano? So, however, more MAS must be used because of the effects of direct square law. So, kung malayo, kailangan mas mataas yung MAS. Sabi nga natin, mas tataas din yung exposure factor or radiation dose ng pasyente. Okay, so if you have questions, do not hesitate. So, I recommend you to read our references. So, and again, thank you so much for watching, and that would be all. So, see you next week, and goodbye.